Hello students, this is regarding one question asked in ICSE Physics Board Examination 2025 conducted on 17 March. Question number 9, third part of the question. A copper rod which is carrying current is placed between poles of a bar magnet, two bar magnets in fact, and what is the force experienced by the conductor if the cross section area is doubled and length is kept same? Now, it's very simple explanation for a class 10th ICSE board student will be the force experienced by any current carrying conductor placed in a magnetic field we know is given by F equal to ILB sine theta. So, ILB indicates current flowing through the copper rod, L is the length of that rod and B is the magnetic field. So, it depends upon length and not cross section area. So even if you change the cross section area, you decrease or increase the cross section area, it is not going to affect the force experienced by the conductor, that is the copper rod. So very simple explanation is no, it is not going to affect any change in cross section area will not affect the force experienced by the copper rod in the magnetic field. Now some teachers have given wrong explanations. I have seen some YouTube videos where I have seen some teachers giving wrong explanation. Now where they went wrong is that I found one particular teacher explaining that since if cross section area is more, resistance will be less, and less resistance will mean flow of current, more flow of current, and this means since F equal to ILB, he meant that the force will be more, but it is absolutely wrong explanation, because here the current I simply means the source current, which is the DC source we are using, a cell or a battery. So if you change the cross section area, it is not going to have any substantial effect on the force experienced by the copper rod. So very simple answer is F equal to ILB. So in that case, since it is not going to depend upon cross section area, the copper rod will not experience any change in the magnitude of the force, so it will remain same. Remember, if you move to class 12, for a class 10 ICSE board level, this explanation is self-sufficient. Now if you move to class 12, you will understand, if you go through NCERT book, you will find out force experienced by a conductor in a magnetic field. Of course, we can consider a few things like a charged particle is moving inside the conductor, and then it will also experience a force, etc. But overall, when you equate the equation, you will find that the equation comes out to be F equal to ILB. So basically it means you change cross section area, you decrease, increase, you do whatever with the cross section area, it is not going to have any effect on the magnetic field. Another thing, very important point I would like to tell here is, any conductor which is placed in a magnetic field which is carrying current does not experience force due to its own own reasons. When it is placed in some external magnetic field, it experiences the force due to that external magnetic field. So you make any kind of changes inside that conductor, it will not have any impact on the force experienced by the conductor. Only of course the current, if you talk about the current which is coming from the source, say DC source, so that will of course increase or decrease. If the current increase or decrease, in that case the magnetic field, the force experienced by the conductor may increase or decrease. So I hope this explains well to the ICSE student, and if you still have any explanation, you can comment on the comment section. Thank you.